Hi there, I'm Zeke, KJ7NLL, and today I'm going to be talking to you all about the LNA and push-to-talk systems with the triplexer on it. Actually, it's a diplexer. We went over that a couple of videos ago. So, now it's time to show you the LNA. So what we have here is the open LNA board. We went through a period where we were trying to calibrate with LNA boards, so that's what this is. This is the open board, and you need an open, short, load, and through to calibrate. So we have the open board here, and this open board is connected to the battery. So let me show you how this works. We have the battery, which plugs into the power bus. We have the ground, which comes around here and connects into the ground of the power for the LNA so that the LNA can be powered. We also have this line here, which connects to the input so that we can measure when the voltage goes high on here, because that's when it turns off. Now I also have it hooked up so that when I push this button, the light turns on and we connect power to here, but we disconnect power to here. Remember, it's an open. So what we're going to do is we're just going to do stop, and then what I'm going to do is I'm going to hold down the button, which lights up this light, and I'm going to hit run, let go. And what you can see here is, starting from the left, we have the point at which it turns off, and then we have low for a little bit, and then high. Now this is what we want to know, the distance from there to there. So we can do cursors, T1, and move that here, and then T2, we can move that to here. And the distance between them seems to be 1.356 milliseconds. And that's just perfect because our Icom goes up to 30 milliseconds of delay. So we just were on the very safe side and did 15 milliseconds, which is quite a bit more. Anyway, that is how you measure the timing for the relay to switch. 1.2 milliseconds is just awesome. So here we have the Nano VNA connected to the triplexer, which is connected to both of these LNA boards. And these LNA boards get their power from this push-to-talk board, and this push-to-talk board is connected to the radio here, which is connected to this push-to-talk button. This is the first time we've had it wired up this way, so let's give it a try. So first things first, we have the Nano VNA connected to the 2 meter, and so this, when it's receiving, is floating on the white wire, and when it's transmitting, it's a hard pull down. So we connected a resistor from the white wire to 13.8 volts, and now it's working great. We were connecting it as a pull down to ground, but its pull down is already really strong, and its pull up is not very strong, which means it's just floating. So you can see the LNAs here, and you can see the little bit of red light reflecting off of the triplexer board. The triplexers, when the LNAs are turned on like this, have a very good SWR on the this is the 2 meter board, and it has a very good SWR and a very good reflection over here at 1.18 and 1.20 SWR, and negative 35 and negative 34 on the reflection. So when I hit this push to talk button, you'll see these lights go out and these numbers will come down. So you'll also notice this LED I made goes out, and this LED is connected to the LNAs on the center pin, and the center pin connects to power for the LNAs. Now you'll also notice the red light went out over here, and this isolation got better because the LNAs are now going into bypass, and we're just going through the triplexer here. Now the way this works is it takes 5 volts and puts 5 volts down this row we also have 13.8 volts here, which its only purpose is to connect to the white wire as a pull-up. So we also have two FET transistors here, which are used for making it so that when this 13.8 volts comes in here, we take the 5 volts and send it through to the LNAs, which is also why when I push this button, this light goes out. Now we also have the ground over here, which is connected to this blue LED, and this red LED is just the power LED for when we plug in and out that power. And that's basically how the push to talk button works. So now I want to talk to you a little bit about the schematic of this push to talk circuit for the LNA here. So when I'm not pushing the button, like you saw, the LED here is off, which is the blue LED. And the way this works is when I'm not pushing the button, 13.8 volts easily comes through this 10K and overrides the floating voltage here on the send. Now, when I am pushing the button, this goes to a hard ground and makes it so that the ground overrides the 13.8 volts, which also means that almost no voltage gets past this point and into the gate to turn our LNA on. Which is why we can use the 13.8 volts with a pull-up 10K ohm resistor on this to switch the LNA on. Now we also have a 5 volt drain going into the source. When this is grounded, we are transmitting, which means we do not want the LNA connected, which means that there should be no voltage here to turn on the N-channel MOSFET. We are using two 2N7000s. Now, usually you are in a 5 volt circuit, and with 5 volts here and 5 volts here, that won't pass the threshold voltage and it won't turn on the FET. However, with our 13.8 volt power supply, we can come into here and pass the threshold voltage for the source here and turn on the LNA. Now I've also set up a little resistor with a LED here. This LED connects to ground over here. Now the LNA, when this turns on and passes the threshold voltage for the source, we get voltage through the 5 volts, through to the source, and onto the LNA, which is why we turn on the light. And then, that's when we're receiving. When I close this gap and we transmit, no voltage gets through, this gap is closed here, and the LNA turns off. That's the schematic for you guys. Now let's check out the 70 centimeter. When the 70 centimeter LNA is in bypass, when I push this button, now we have 1.53, 1.22 in bypass, so this is just through the 70 centimeter on the diplexer, and really good isolation with negative 50 and 40 over there, which is just amazing. And that's what we care about with these in bypass. Also here, when I push the button, you notice that when I release the button, this goes up to 22 dB of gain through the LNA. So that says that the LNA is working. Well, that's how we were able to make our push-to-talk circuit to turn off the LNAs when we're transmitting so we don't fry them. And I will be presenting at DAC. The registration link is below, and so I hope to see you there. 73, characteristic dipole impedance.